Okie dokie. Well, good afternoon. Yeah, it's afternoon here in Cologne. Welcome to Tapestries of Data. This talk's going to be about monitoring and a bit of management of PASOE instances using JMX, which is, I'll explain what that is. Just a quick, is anybody running PAS instances in production, monitoring them at all, using JMX? Anything? No? I asked for one hand. No, just one hand. No, that's good. All right, so we'll talk a bit about that. Anybody use ASB-man? Has anybody ever used ASB-man for Classic AppServers? Okay, so we'll talk a bit about that. Yeah. All right, so my name is Peter Judge. I work at Progress. I've been there forever, it seems like, for a long time, since 2003. My background is in application, toolkit design stuff, coding. I'm a coder by heart, still what I like to do. And lately, I've been working with a bunch of our customers on migrations to PASOE. And a lot of what I'm going to talk about today has come out of those kinds of engagements about requirements they have for monitoring, for managing, those sorts of things. If you have questions during the session, just raise your hand or ping Gilles on the chat, and I'll answer them as we go. Right. So what are our kind of goals here? I started out with, well, let's just talk about generally JMX stuff, and there's a lot. There's a lot of things you can do to PASOE with JMX queries. Lots of little detail that you can work on. But I also thought, well, people are used to using ASB-man to manage their classic instances, their classic AppServers, right? ASB-man minus Q, you can see what's running, what's busy, what the queued lengths are like, those sort of things. Either scripting it or using, manually, however they want to do. I know there's people who screen scrape the tools, the output of ASB-man. Also, people remove agents from service, right? You trim an agent because you've scaled up and your load's gone down, or there's a big fat memory leak in somebody's code. I won't point any fingers. But somebody's code, and so you just want to close stuff down, you want to minimize it, you want to keep them clean, or you're just neat and tidy like we all are, right? You just want to make sure you have clean instances. And you can use the ASB-man trim servers, or agent stop, or even agent kill switches, and you can trim stuff down. So what we're going to talk about here is kind of replacements for those two things and how you should do it and when you should do it. PASOE's architecture significantly differs from Classic in terms of the number of components, where they are, what's responsible for what, and also what information we can get from all of them. I'm going to assume everybody has got an understanding of the components. I'm not going to talk much about them. A little bit I'll talk about, but not much, so hopefully there's an understanding of that. So in the Classic world, we have UBoker properties and DLC properties typically. You can move it around, and it's got chunks of things that look like this, right? Definition ASBroker1, ICF repos, yada, yada, yada. Each server runs a single process, has a single ABL session, and can service a single request at a time, 111, right? So you can't have two requests going into a single server at the same time. Server has a single, unchangeable, immutable operation mode, state reset, state aware, all of those fun things, stateless, state-free. App servers and web servers, or web speed, are separate configurations. They even have separate names. One of them is a broker and server, one of them is broker and agent, or server and agent, and I can never remember what it is. And then we have our friend the admin server that sits in the middle of all of this and makes sure everything doesn't fall apart in a heap. Did I miss anything for those of you that have worked with these? I think that's basically, that's the important stuff, right? I hope. PASOE, okay, so here it's different, right? There may be many instances on a host, on a machine, right? Like you can have many app servers. The huge fundamental difference in the configuration is that each PAS instance is in its own directory, and it is not in DLC. It can be, it should not be allowed to be in DLC. Please don't put anything in DLC that are instances. When they're running, they are uniquely identified by the host and the port. So you can create a whole bunch of them with the same port number like I do on Development Box. I've got about 7 instances that are all 8810s. I just don't run them all at the same time because the network doesn't like that. All registered instances in an OpenEdge install are listed in one of those files, an instances file, so you know where to find them. And the act of registering an instance with an OpenEdge installation with a DLC is basically to say, hey, instance, that's where all of your executables are. That's where your multi-session agent executable is. That's where the Tomcat executables are. And it hooks those two things together. And so when you create an instance, it automatically registered. But what you can do is you can create an instance, unregister it from one install, and re-register it on another install, which can make deployment quite nice. So you can, in theory, zip up the whole folder, plop it onto another machine, register it with the DLC that's on that machine, and you're good to go. Each instance contains what we call an ABL application. ABL application is effectively ProPath database connection configuration. Basically says what's the configuration of those agent processes. That's kind of at the very high level. Each one of those can have one or more multi-session agents. Now here's where the difference comes in. Each multi-session agent has many AVM sessions, ABL sessions, right? So that's what the multi-session comes from. The sessions can process multiple requests at once. Sorry, the agents can process multiple requests at once. So one multi-session agent can process up to, there's a configuration for it, and I always forget which one, so I won't say it, but you can process, you can have, by default, we say there's 200 ABL sessions in a process, in an agent process, and you could connect up to, I think it's also 200 connections at a time. So all 200 can be busy at the same time in a single process. Right. So the agent is multi-threaded, the sessions are still not multi-threaded. The AVM is still single-threaded. The agent connection mode is dependent on the client type. I'm getting lots of thumbs down here. No. It's dependent on the client type or the application code. So to emulate state reset or state aware sessions, you have to write some code, whereas previously you just said in the new broker properties it's state reset or state aware. All of the clients are serviced using the same pool of agents, pool of sessions. So whether they're web speed requests or whether they're Classic AppServer requests, they're all serviced by the same set of agents. There's no distinction between web speed and AppServer brokers or servers or anything like that. And there's no admin service required. You can run an admin service to do the administration, but you can just run it pretty naked. There's no name server, and because it just can run without any of that infrastructure around it. So JMX, Java Management Extensions, are a technology that is used to monitor and manage Java components through these things called managed beans, mbeans, and they instrument a resource. We'll talk about what those resources are as we go through in the Java world. And PASOE or Tomcat uses them, right? So you can get at these values through attributes or methods. Some of the tools like attributes, because it's easy just to run down, just to recurse and see everything. Methods are a little more complicated. PASOE tends to use methods, not for any particularly good reason, but we just do. You can see, using the all of the queries that are available for an instance. And so when you run that on a PASOE instance, Catalina base is the instance directory, the instance root directory. You run that command and you get, I don't know, there's probably 200 of them or 300 of them. Some of them are per web app, some of them are for various levels of complexity. So you can see what they all are, and they have a little description, and you can plug them in. A lot of data, though. So to get at this data in our OpenEdge world, right, we basically have two tools. One is a batch file or a shell script called JMX, which lives in that instance directory, again. The other one is the OE Manager REST API. And so you'll see there's green and yellow there. And I should have maybe done them slightly differently. But green and yellow, the green ones, where you see highlighted examples, that's going to be the JMX commands. The OE Manager are going to be the REST API. There's tons of other third-party tools that you can use. JConsole is a standard Java thing. Mission Control is an Eclipse plugin that's very pretty and looks good. And thanks to Gilles for pointing that out to me. It's like very nice. Jalokia is another one which uses the same extensions to provide the data out in different ways. So this is kind of a bog standard mechanism to get data, monitoring data and management data out of an instance. Right, so with the OpenEdge variants, you can think of them as service interfaces. They both funnel into the same place. whether you go with the REST API, whether you go through the shell script. You get the same data back. There's slight differences. We give you data back as JSON. OE Manager gives you an envelope. I'll show you what that looks like in the next slide, I think. JMX typically doesn't, except for one place. Why? I don't know, but it does. And there's some small differences. The bigger differences here, or the biggest difference, is local versus remote, right? So JMX, you have to be on the host, on the machine to run the command, right? So you need, that implies that you have access to that machine, that you have a login, that you have permissions to, OS permissions to run that script, right? So there's some built-in layers of security. OE Manager is just the REST API. And so by default, it's fairly unsecured. And that's why it's not enabled by default on production instances. You have to go in, install the OE Manager web app. You've got to go configure security to make sure that it's not just an open thing. Because as you'll see, you can't just read information about instances with these APIs. You can affect the instance. You can change properties. You can kill things. You can start things. You can have all sorts of fun if you leave it open and unsecured. So a couple of things to note about these tools. Firstly, JMX shell script is what I prefer. It's good, but it is a little slow. Quite slow, little slow, how should we say. What this JMX script does is it basically connects, it starts a JVM when you run the script, and it connects using some virtualization technology to the instance's runtime, and then executes the queries there. And that connection takes a fair bit of time. It might take half a second, it might take a second, it depends on your machine, but it is comparatively expensive. There's a way you can mitigate this by having a file with many queries in it, which means one connect and then n runs, so you amortize the cost over the runs. But as I said, it's always there for always on. We have had a couple of customers ask/complain about the performance and the time it takes and the CPU load that the JMX script adds, and we're investigating ways of making that better. There's some other ways we found, but some ways we found already, but that's still in the development phase. The OE Manager REST API is faster. Why? Because it's running in the same JVM as the instance, right? It is in the instance, so it doesn't have to do connections to anything because it's there already, right? That's much faster. There may be security terms. As I've talked about these things, it's not on by default in the production instances, so you have to either use one of those two commands to get the OE Manager, and then you can run your JMX queries on there. Okay. And again, most of what I'm going to show you here is on the OE Manager APIs, but the outputs and the commands are very, very similar based on the JMX queries. All right, so first we'll look at monitoring. And so everybody should recognize that. That's an ASB man -Q output. It was on my development machine. It's not very busy, but you can see, broker status and type. You can see how many servers they're running, how long they've been running for, all that sort of stuff. So part of what we'll walk through is how we can emulate that in PAS terms. So the first thing we really, really want to do is turn metrics on. They're also off by default because there's always a little cost in managing them. And so we can enable them this way. Typically, you're going to want time and count-based metrics, and we can do that dynamically as well. So we can set it in the OpenEdge properties file. OpenEdge properties file lives in the instance's conf directory, so it lives together with the instance. It doesn't live with OpenEdge or DLC install. And there's ways of setting it as well. So we could turn it on for a while, do some monitoring, turn it off if it proves to be too expensive. But I think typically as you monitor these things over time, you're going to want to gather the stuff every n seconds, n minutes, whatever the monitoring interval is that you're interested in. So we start from the top. So the highest level, the outermost thing we can look at and we're just going to look at the OpenEdge side, right? The OpenEdge side. We're not going to look at Tomcat's queries about thread pools and connect accounts and that sort of nonsense, which you can do. But we're just going to talk about the ABL side. So the first thing we do is kind of run the ABL app, and we can get one or more of them, right? We can get all of them, we can get one of them, and the thing we really care about here is its name. Now, typically when we create an instance, the name of the ABL app is the same as the name of the instance. So you say OEPAS1, instance called OEPAS1, and we'll have an ABL app called OEPAS1, which is really confusing, because which one are you working with? I know it's confusing, Confused the heck out of me when I first ran into it. But for this purpose, we only really care about this. This is, this is the envelope you get from PASOE, so this operation outcome result and the error message, version number string, that stuff. That's the, I'm late for a meeting. And clearly they're not watching me, thanks guys. No, that would be, sorry, that would be the envelope that you get. You don't, typically with the JMX queries, you'll just get this chunk of JSON, application, that array. You won't get the whole wrapper around it, although for this one you do. Web apps we don't care about right now. They can tell you information about what's deployed, whether the transports are enabled, various other things. Some services that are deployed, it's a little lacking in some places. You can't see what services are deployed on the web transport, but you can see them on the REST and on the SOAP transport. Anyhow, but for this purpose, we want to get that name. You may know that name already. Typically, or a good practice would be to have one ABL app on your instance, because it just makes the management of the whole thing so much easier. You don't have to pull them apart if you want to deploy things separately and whatever. So it's a good practice to do that. Click. Click. And it's... Did you change focus when you... Yeah, I must have changed focus when I did the... Yeah, I changed focus when I did the thing. All right. I was a little worried about that. Okay, so the next kind of level. So one of the things that you'll see two large buckets, if you will, in the JMX queries of session manager and agent manager. And you can kind of think of them as the session manager stuff is mainly on the side of Java. So Tomcat is Java. We have our, what we call the session manager, which sits in the Java web app, and it manages the communication with the agent, right? The agents are C processes, and there's however many of them. The requests come into Tomcat. The session manager gets them and says, I'm going to send them wherever they need to go, right? I know they need to go to this agent or this session or any one that's available, whatever. They manage all of that communication. So a lot of the kind of queries you'll see are either agent manager or session manager. On the session manager side, we can see metrics, right? So these are quite well put together, you know, metrics, and then clients request sessions, whatever we need to do. And that was with all the metrics turned on. Number of writes, concurrent clients. There is a bug in this one, max concurrent clients, where we don't decrement it when we don't decrement it properly. So it just keeps growing and growing and growing. So you don't put all your faith in that one. But generally, this gives you, you know, a whole bunch of information, doc here on what exactly those are, right? So that's one level of timing metrics and throughput metrics. The second thing to look at is the session manager sessions. As you may have guessed, the session manager manages sessions. Right? It's like a factory service of session manager manages sessions, right? Something like that. Sorry, that was just a joke to the previous session. Manages session manages sessions. Now a session manager session, remember this is on the Tomcat side, not on the agent side. And these tend to be transient, right? So if you're just taking web requests or REST requests, these are going to live for as long as it takes to service that request, and then they're going to vanish again. They just come and go and come and go and come and go. When you are running ABL requests from ABL or APSV, what we call APSV clients, for open client, ABL clients, these may linger. So if you connect with session managed, there will be a session. This is the session that's being managed. I'll put it that way. And so there's this information stays around if you have session managed sessions. If you bind a session, right, if you do those things that we've been told not to do forever, and you run something persistent on the server and you never clean up the handle after yourself, you bind the session, one of these will carry on hanging around. So these things you should expect to see come and go, not hang around. Got a bunch of interesting information. They've got, you'll notice over here, up here, so it's got a session ID. This is the session manager ID. This one over here is a web request, and it's got that kind of a format. You'll see session manager IDs later, which have a slightly different format. The agent ID over here is this gnarly string, and generally you can use that string, or you can use the agent PID as an identifier for the agent in the instance. Session free, running. We have some information. This one's obviously running a request, so it's got information about the client connection, right? Where's it coming from? Cotton Eye Joe, where's it going? One of the important things, request ID over here is very useful, and that's a unique identifier of a request. So per web app, per transport, that's what the W is for, and a counter, that gets pretty big. And so you can use that to identify a request flow all the way from the Tomcat side, from the access log, all the way back into the AVM, not quite into the database, but all the way back to the AVM. So you can follow a trace of a request using that identifier. Not up to the database. The question was, does it go all the way to the database? Answer is no, not yet. No, not yet. You could, I mean, I think the way you would have to do that is you would, if you set up an audit policy or something, and you could push this is custom, you know, audit data into the audit policy, but not natively. The other thing to note here, which is also, so there's some interesting behavior. This ABL session ID over here, right? So typically you use the agent ID and the ABL session ID to identify which AVM session we're working on. That value is only filled in when this is bound. So not when it's session managed, which is a little annoying, but so you have to do a bit of jumping to and fro sometimes. Again, doc on all of those. Another chunk of information, right? So this is useful for the client, very useful for when did the request start. Some of the information is duplicated. I talked earlier or previously about clients and requests and sessions. Oops, go forward, go forward. There's the connections. The request information is not in here because I don't think I was executing one at the, no, there must be one there somewhere. But the sessions, clients, and request information is also in there. So this is a good piece of data to get. If you're going to gather one thing, this is pretty powerful or pretty useful. The next thing we can look at is what are the current requests executing in that the session manager knows about, that are currently executing for an ABL request, right? Current. So no historical data, what's happening now? And you can see that that shows through the whole pile. There's our request ID. On the Tomcat side, where's the URL? When did it hit Tomcat? What was the method? In the session manager, pretty much when did it get there, which is not too much later, right? 8, 9 milliseconds later. What is it doing? What's the user ID from the authentication into the agent? Gives us the actual ABL session ID that's running. What's the program that's running, right? You can see it's a web request. When did it start? And what's the request num? So you'll see there's a request num here as well. That's not particularly useful. It's used, I'll talk about it a bit when we talk about agent sessions, or sorry, agent requests. But the request ID at the top is the one we really want. The challenge here is if you want to figure out which actual agent that request is running on, you've got to go back up to the sessions. The session manager sessions using the session, using this session ID. And then from there, we say, oh, there's that session ID, there's the agent ID. So we've got the agent ID over here, plus agent.session ID, which gives us the actual ABL session that's executing. Fun. Fun, fun, fun. All right, so moving out of the session manager into the agents, we can get information about the agents, right? We get an array of how many agents there are, what their PIDs are, what their agent IDs are. And usually we can use the ID or the agent ID to identify an agent. There's one or two of the queries that you can only use the ID, so this longer string, not the PID on. And that's kind of why the queries are all, the JMX queries are all in quotes. Jill.
There was a question about getting the ABL call stack. Oh, there was a question about getting the... Okay. There was a question about getting the ABL call stack of a given session, like using pro get stack.
Yep. Okay. We will, near the end, there's some extra queries, but it's possible to do that. You can get the ABL call stacks for an agent, for all the sessions in an agent, or you can get it for an individual session. So there is a query for that. And it might even be called get ABL stacks or something like that, or session stacks, I think it is. So there is an API for that. Lots of information. Metrics about the agent. Some of these are more useful than others. I've been told not to look at that CStack memory number because it doesn't actually mean very much. Overhead memory is kind of what you care about here. So if you wanted to say, I want to trim an agent after it gets to a particular size, amount of memory usage, you can use that number to do that. Right. Next, into agent requests. This is one of the only bits of historical data that we have available in JMX queries. This returns you up to 1,000 requests for that agent. We store a lot more, but there's code in there that just blocks it at 1,000 because in testing they ran the API on a system that was being used a lot, and some memory stuff happened and things fell over. So there's a kind of an artificial limit for 1,000 in here. So what's nice about this is now you can see historically over time all of the requests that went into a session, right? So we can say session 7, like I've trimmed this off, but we could see all of them over the course of time, including the current one. And what's nice about that is this little guy, request status, which tells us what the outcome was. So 0 means it succeeded, but if there's a 1, 2, or 3, probably just a 1 or a 2, you may say, hang on, I'm getting errors in my ABL session in these requests, they're not executing properly. What am I going to do about that? So you may decide that you've got some corruption in your, your temp tables, you may have some other corruption, or you may be timing out, right? You may hit a stop after limit, something like that, and you may want to trim those servers, take them out of commission, or you may want to, just put stop traffic flowing to that instance if you're using a load balancer, right? So you can detect what's happening, what has happened, right, over time.
Here.
Yes?
Is there any way to decorate this information about what you actually were doing there? Because it's all internal web handle request.
Yes.
And it's not very informative.
So Bronco's question was, is there any way to make, for web requests, this more useful, this request proc name? And the answer, unfortunately, is not yet. The request proc name over there is the .p or the run in the agent. So if you're running, if you look at these requests for an ABL client, you'll see, get data or get customer tax information .p, right? You'll see that. For REST, you'll see whatever you've mapped it to. But because of the way web handlers work, the piece of ABL code that's run in the agent as the first piece of code is that. We've talked about trying to expand some of the context information to make it better. But unfortunately, right now, it's just what you would probably have to do here. Well, what you can do here is, right, you've got this magic number, and potentially you go back to that magic number, right? And now you know what your URL is. You've got your method, but you'd have to gather that as you go. So you'd probably have some kind of a short interval to do it, right? Exactly. So you can get, so that's actually a very good point. So you can take this information, this, and that, and that, and the status code, and the execution time, whatever you configure to do, are in the default access log. So you could just get the request ID out of the historical agents, go back into your log files and say this is what the actual thing was, if you want to do something like that.
Yeah, and it doesn't need to be the access log, it can be
the agent log. They can also have logging that you did during that request from the ABL code, like maybe query info.
Yes.
Or
so,
4J trace, or how it's really go.
As Mike says, all of the log information that's written into kind of the header of the log is, timestamp, a thread ID, a process ID, and this request ID is also written by default into at least the 12 logs, and you can turn it on in 11.7. It's in the doc. I can find it if somebody's interested. How you can turn the request ID on. So that's another way. You could write your own logs out, but again, it is available in the default logs, or in the standard set of logs, I should say. All right, so requests. The other thing is just that is available. This request ID, the request proc name are both available off this current request info, which is an object, returns those two pieces of information, and also handily the session ID. There's no other way of finding the session ID, and handily the current process ID. So you can't find it in the startup procedures, unfortunately, but you can find it on each request. You can take a look in the activate, and you can see what the thread is and what the current session ID is. So you'd see 7 and whatever. What were my numbers back there? 2229 or whatever it is. You could see those out of the current request info. Lots of useful information there. Right. Down into the sessions, right? So again, yet more sessions. These are the ABL sessions in the agent, right? So you can see it's kind of keyed off of agents, right? So for that agent with that identifier, that's a PID, just because it's short on my slides. But we could put that in, the longer, we could put the longer identifier in there and get the sessions. This is the list of current ABL sessions that are available to do work, or they might be doing work right now, right? So they have the session ID. What are they doing? Active or idle? When did they start? When did the session start? You'll see the thread ID, connection ID are -1 for the idle one because it's not doing anything. But this guy's busy doing something on thread 4 and on that connection ID, right? And the other thing that may be good to know is the memory use here. So you can identify how much memory each session is using, right? So maybe handy to identify leaks in advance, or you may just have a hard cap. You can say, I don't mind if I leak, I don't mind what my leak looks like, I just want it to stop at half a gig per session, or whatever number it is you pick, right? Whatever that size might be. All right, so that's kind of session information, just to map it back to the ASB-man output. There is no broker. There's no real concept of a broker in PASOE. So you've got to take that out of your head. So there's some of the stuff we can get from the session manager, some of the stuff we can get from the instances. But the most important thing with all of this stuff is, and I'll say it again, for where we thought of servers before on Classic, we think of sessions now. Sessions are the things that do the work. The process doesn't, the session does. It's important from a management particularly point of view. So just mapping back some of this information that I've shown you, how can we aggregate those values back into what we had before? Important things to note, right? Broker port doesn't exist, right? Tomcat or PASOE may have 1 or 2 ports, right? HTTP or HTTPS, and you may decide to turn one of those off. So kind of the locked ones, how many are bound, how many are available, you can do the maths yourself. On the server side, similarly, where do we get that information? And so we can bring something down to here, but we can kind of emulate that data that looks very much like that, right? It looks almost identical. Why would you want to do this? Maybe you don't want to change your tooling right now. And this is quite, it's quite static. This is probably hard to parse, right? You've got to screen scrape it effectively. It's much easier to parse JSON, right? JQ, who's used JQ in Unix? If you haven't, it's a magic tool, really is. It just, you give it a blob of JSON and you can search it and you can color it and you can format it and you can do all sorts of fun things. It's a really cool little tool. All right, so now we've got a whole bunch of information. What are we going to do with it? Kill them all? Well, not. No. There's other things you can do. PASOE is actually very good at scaling up a lot of the time, making sure it's got enough sessions and agents. You configure how many sessions per agent you want, what the minimum available should be, how many agents there should be. It manages scaling that stuff up really well. So I'm not going to talk about how you can't start any sessions manually, even ABL sessions, but you can start an agent manually. So you can so if you wanted to create a warm spare, you see load starting to increase, you say, let me just add another one just in case, because it takes me 15 minutes to cache everything out the database and put it in the temp tables and blah, 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 whatever that might be, right? So you may have, I know there's plenty of people who cache a lot of stuff into the sessions when they start. So here we're going to talk about cleaning up after yourself, cleaning up the mess a bit. First thing we remember, agents are friends, not food. You really don't want to be killing an agent. Thank you. Somebody got the bad joke. You really want to be not stopping an agent if you can help it, because you're not just affecting one request or one current request, right? Typically you're going to have, I don't know, anywhere from 50 to 100 or 50 to 200 sessions in there, and you may have multiple requests running simultaneously. And if Bronco's session spirals out of control because he passed in a bad query, I don't want Luke to get angry with me because I had to kill Bronco's session, right? We just want to keep it, the focus here is on sessions rather than on agents. We'll talk a bit about, you can terminate an agent, but we really want to focus on refreshing agents rather than terminating them.
Is it possible to assess the case of memory of session you're actually
Yes, so the question is, can we assess memory leaks? Yes, so we can say, give me for an agent, we can say, give me an ABL, what we call an ABL objects report. You've got to turn it on and off, but what that does is it's effectively like DynaObjects logging. And it just says, this is what's in memory at the current point. So if you look at idle sessions. You say, look at all these idle sessions with lots of memory, right? So you know they're not busy doing something right now because they're idle. How much memory are you using? I didn't expect to see all of that openh.core.logging instances or whatever it might be in there, right? Whatever might be in there. So it'll look at objects, it'll look at long chars. I think, no, long chars are cleaned up anyway. Mem pointers, might be handles as well. So but it looks at a whole bunch of that sort of stuff and says this is what's memory resident now. And so you'd have to...
If you kill the session?
Then it just goes back to 0, right? And then
yeah, but is memory actually giving back to the operating system?
the memory is not giving back to the operating system. The memory is giving back to the process, and the process says to the operating system, here it is. And the operating system will be like, I don't care, you keep it for now. I'll take it when I need it, right? So there's nothing special we do. That's actually the next slide. I'll hop onto that, right? So there's nothing we do in the multi-session agent process that's special with the memory. We don't, like when the session goes away, we claim back that, I don't know, 200 meg or whatever the leaky session was, and we just say, we're done with it. We just free it, right, equivalently, whatever the C is, right? We just say, we're done with it, and Linux or Windows decides whether they want to take it back now or not. But yeah, so it's just standard standard operating system stuff. If you really, really want it to go away, you need to stop the agent. So I'll go from the bottom, right? So over here, we can say, delete an agent, right? So give it a PID or give it an identifier. You can tell it how long to wait to finish. So in case you want to be nice to other people, you say it's grown too big, but I know there's still 10 requests running on it. Give it so many milliseconds, let people finish that, or finish to stop, right? So you can stop them there. But typically, you're going to want to refresh the agent. And what the refresh does is it keeps the process running, terminates all of the sessions in it, and then brings them back up again, or brings a number back up per the configuration in OpenH properties. And so there's 3 ways of doing that. One is with tcman command, and the other way is JMX and the REST API. So you can trim them all, you can trim one, however you choose to do that. And that just keeps the process running, and then the sessions will come up as they come up, right? There's a configuration to say this is the minimum number of AVL sessions I need per agent, and it will bring those up. And if requests are still coming in, they may queue while those sessions come up, or until the first one comes up. Really, the algorithm is, I think, first one comes up, and then if you've got a minimum of like 5, the first one will come up, and that first one can start taking traffic while the other 4 come up. Some of this stuff I should note as well, it's important to understand the kind of algorithm for sending traffic to the sessions and the agents. So our algorithm, our approach is do as little work as possible. So, or switch context as little as possible. So if a request comes in and we use session 4 in agent 1, and that completes and the second request comes in, we're going to use session 4 in agent 1 as long as it's not busy. The next request comes in, we're going to use session 7 in agent 1, session 10 in agent 1. We're not going to round robin across processes. So we're going to keep the context switches as few as possible. So use the same agent if you can. Sorry, use the same session if you can, if you've got a slow system or a relatively slow system. Use the same agent as long as you can. And so typically our recommendation for setting that stuff up is just to start configuration anyhow before you do your load testing and stuff like that. 2 agents and sufficient sessions in each agent. And that means that your one agent takes all of the work, and that's by design. So if you look at the traffic that way, that's how we intended it to be. But it's important to understand for doing things like this, right? If you're going to start deleting this, I believe this tells the session manager, stop sending me any work. So does the refresh. So you're obviously going to need a second agent to take over the work if you want to keep running on the server. All right, trimming sessions, terminating sessions. We've talked a little bit about the information you can use to decide whether to kill a session or not. Some people use time-based, right? Has it been running for a day? Yeah, let's just kill it anyway because I don't trust those developer types not to put bugs in my code or leaks in the code, right? But when did it start? How much memory has it used? How many requests has it done, right? Maybe we just say, we give it 1,000 requests and then we call it quits, right? We just let it run until then. Did they succeed? Were there lots of errors? I talked about that as well. So to delete them, you have to delete one at a time. We've had requests for being able to make one call with multiple session IDs in it, but for now it's just one at a time. And on the agent with the session ID, kill it, and send one of these options. So these are quite nifty. The 0 is the default. It's a trappable stop. So if you went to Mike's talk earlier this morning, or if you were around for that, you could see how you could do that. But basically, the ABL session gets terminated immediately, which is pretty close to immediate, because there's an administrative thread that runs parallel to the sessions, and it does the work of killing the sessions in the agent. So it's pretty soon after you issue the request. Raises a trappable stop. Currently, it's just a stop. It's a little bit hard to figure out why you got that stop. There's no error number, so the error number of the thing is 0, and it's just a progress length stop. So we are busy fixing that. So you'll actually be able to identify it as a stop. Yes, Mike?
So when you say a trappable stop, that means in 12.0, finally blocks are executed along the way.
Mm-hmm. Yes. Just so.
Repeat the question, please.
So the question was, when you say it's a trappable stop, is it a standard stop that's raised, and does that cause the finally blocks to execute? And the answer is yes. It's just a normal progress length stop error maybe, I forget. And yes, it's just from that point, it's just standard unwinding of the stack, rolling through the finalies, all of that sort of stuff in 12. You may want to identify it by having an error number of 0, but that will change as well in the near future. The second one is effectively the kill force, right? With 2, it just kills it, and it just makes the session go away, poof. You don't get any notification, you don't get any raised errors, you've got nothing to catch, it's just poof, gone away. And then the third option, which is nice if you don't have to urgently kill something, is just let the thing finish its request, and before it goes back into use, just terminate it, right? So remember, because of our algorithm, what could happen if you waited till it was finished doing work before you try to kill it, somebody else might come in and start using that session. Another request could come in for that session before you get a chance to do anything to it. So this is just a way of saying, hey, session 12 is broken beyond repair, or it's taking too long to execute these queries. Kill it and just let it go. So 0, 1, 2, right? And this call, the set of calls, this is pretty much the closest. This is what you would do with trim sessions, right, in the classic world, right? This is probably where you want to be doing most of your management on the fine granularity. We also have session manager sessions. I've talked about them in terms of transiency, right? They come and they go really quickly. They also interact. The other thing is they also interact with the HTTP sessions. So Tomcat, the web apps have their own session IDs, and you'll see the number. Do I have a number like that here? I don't. Which is like a long alphanumeric string, dot, and then the web app name, or the ABL app name. Web app name, I think. So those are the session IDs. Remember I mentioned the session IDs look slightly different depending on the transport. That's why it doesn't matter. You shouldn't care about what the number or the value is, just that's why they're different. So those are controlled by timeouts in conf OpenEdge properties. WebXML and context XML standard Tomcat stuff manages the lifespan of the HTTP sessions. And one of the things you need to just be aware of is all of the defaults are set up or largely set up for classic web traffic, right? Normal RESTful requests. But because we can talk to this from an ABL or an open client, we have our favorite use case is person decides to go for lunch and comes back 3 hours later, and then they wonder why they've been logged off, right? So things to think about potentially if you've got lots of APSV clients, is to probably have a second web app that can manage their traffic, because then you can control their timeouts differently, you can control things better that way. More meetings. Sorry. I should have turned that off. Well, that should just turn itself off. Anyhow. Pardon? Set focus, thank you. There we go. So we can kill those as well with an API. Pretty much we just say, we get a session ID, we get a list of so we can terminate the session manager sessions with this bottom command. We get a 500 status return to the client. So if somebody's busy work, so as I said, typically they're there when there's a connection and somebody's doing some work. So if you kill them, the person's going to get a horrible message. It's a really horrible message in the APSV client, in the ABL client. But you're going to get a 500 status returned. The session manager session goes away, and the associated ABL session goes away, right? So that's why we have that. On the end there, we have the 0, 1, and 2 again, that you can choose how that should be done. Not entirely sure how 2 works in conjunction with this. If you're killing the session manager session, why would you let the ABL session go? But I have to ask. Not sure. You could also kill the HTTP session. So what may happen is that if the HTTP session expires, it says, hey, session manager, I'm dead. And if session manager's got a session with the same ID, it says, I'm dead, and kills itself down. So you may see cascading cleanup happening. So you could potentially, if you had hung or stuck sessions, something's just not letting go because there was a network error or something horrible went wrong. Better in the 12s. In the 11.7s, there was some miscommunication, shall we say, between the Tomcat side and the session manager side about when a session manager session was there and an HTTP session was not, or vice versa. You probably don't have to worry about that, but I leave it here just for information. Things to look at is if you have no sessions here and a bunch of sessions in the session manager, something's gone wrong, and you could probably clean up them after yourself. All right, active requests, if we want to terminate them, we can see when they started, we can see how long they've been running for. This time is in elapsed time, sorry, the elapsed time is in milliseconds, so we can say it's been running for too long. You can manage some of this behavior with, there's a stop after setting in the properties file, which basically says don't let requests run longer than whatever it is, 30 seconds. But you may have different requirements based on the client type, right? So for a web request, you may say, I don't want any request to run longer than 500 milliseconds because my users are going to get, they're more sensitive to that. For my GUI client, they're used to taking a long time to fill all of the temp tables and all of the grids and all of the everything, so we give them a minute or whatever the number might be. So this is a way of managing individual requests or individual transports, if you will, in terms of management of time. If you wanted to manage how much memory a request is using, you have to look at the ABL session. We don't keep a track of it on the request side. All right. So just kind of other ASB.man commands, and there's a couple more here. Get all, I kind of try to map them across. Again, the trim, please don't kill the agents. Please work on the sessions first. You can add certain agent detail, agent stop, client detail. This is an old, no, sorry, that is right, delete all sessions, right? That is the request call, OE management, only OE manager, refresh all. So kind of just to map that back to here. All right, so JMX gives us tons of granularity. I've just, there's, if you go look at the, I might even have them open. If I go look at the, I'm not, like, oops, go away. This is the, right, this is the, on my development instance, this is 10,000 lines long, of which half are the JMX commands. So there is a ton of information available there. We've talked about some of it. Most of it, to be honest, is around the Tomcat side. But there's a lot of open edge stuff. So look for session manager in there, look for agent manager. A lot of information, right? You can get a lot of detail in parts. And one of the challenges with all of this little detail is, if you look at what we had to do, look at all of those commands we had to do to put together the high level view. You need to understand how the different pieces are related to each other. How does a session manager and a request and an ABL session and an agent, how do they relate, right? To be able to find an overview of that information. And how do we look and work with them? So all of the stuff we've looked at here, right? All of those GET REST calls, all of those JMX calls, you can do the same stuff with JConsole, or you can do the same stuff with mission control, right? So in your Eclipse thing as well. It's a kind of standard interface to interacting with your sessions. And with that, I think I am, how am I doing on time, by the way? Pardon? Not too bad. So if there's other questions or comments, or if you, I would say if you want to see something, I could try, but that never ends well. No, not never ends well. I'm doing a demo tomorrow. It doesn't always end well for me on demos.
Yeah, not totally related, but I think you can answer. When you do a -dt parameter,
yep.
what is actually consuming that memory you allocate there? I mean, In the Classic AppServer, it was pretty obvious. I mean, you had X server, so you were down on memory X times whatever you specified with minus PT. But what is your memory consumption when you do a minus PT with the PASOE?
Just to repeat the question is, what is the BT memory composed of with PAS, given that there's one process or 5 processes with very many sessions? I don't know how we manage all of that, to be honest. I know that there were changes made to the LBI files and the SRTs, you know, the local temporary files, to deal with the fact that the one process has many different sessions that may be, or different threads actually, that might be writing in and out of there. But I don't know how we calculate, how we manage that size. Sure.
You had a discussion with Sébastien Lacroix some time ago. So he has a question about having sub-second value for lock-wait timeout.
I appreciate all the DBA.
Parallel, so that would be a question for Rob Strait in Peter's defense.
I don't know. Mike, DBA question?
Sub-second is one thing. I think 1 second would already be a good start. So the minimum value for an app server is 10 seconds, which is horribly long.
Okay. As you said, Mike is probably, not Tom, Rob, like is probably a good person to talk to about why he's not physically there. But
I would say a sub-second lock wait timeout, then you can just use no wait.
So maybe you repeat that for Sebastian.
So Mike's comment was a 1 second lock wait timeout value would probably be adequate. If you want to use a sub-second, his opinion is it's probably just worth doing a no wait rather than bothering. Yeah. So if there's no more questions, then I'll say thank you very much and talk to you soon.